Hi, people. Welcome back. The session two of the merit paper discussion. So we are going on with the discussion of our merit paper. So in our last session, you might have seen we have been discussing on our merit paper, a quite good paper, which are a lot of things to learn throughout in here. And today is the second section where I will be discussing on the two major questions in the part two section. Right, so let's get started into our merit paper discussion, pack number 4. Write the most appropriate term for the following list in the each of the given. So we do have EEPROM, a type of a ROM, a read-only memory, which will hold all the startup configurations. And ROM has a program called what? Do you remember? We call it as BIOS Kilikino. ROM has a program called BIOS. Make EEPROM Kilikane electrical erasable programmable read-only memory. Again, you can normally ROM a read-only memory. You can't erase it, but this can be erase it electrical erasable. Erase करला program करना पड़ेगा. Blank discrete time period that are used to divide the shared channel so that there won't be any collision. It's a kind of a communication protocol when different devices are communicating, okay, especially when two switches or two routers are communicating. Let's assume we have a PC and a switch. මෙන්න මේ communication එක ලස්සනට කරන්න we have a protocol called Aloha protocol. Aloha protocol එකේ we have time interval, discrete time interval. Again, හැම වෙලේම they can't send messages. You have to send on a discrete time interval. We call it as slotted Aloha. You have open communication නැකැන්න පුළුවන් pure Aloha. So there are two types of Aloha protocols. One, we do have it as slotted, which we call it as a discrete time interval. So make the answer slotted Aloha. So there won't be any much collusion, but you send whenever you wanted, we call it as pure. A ROM is a type of storage containing non-volatile permanently can be only read but written. But blank can be programmed and erase it electrically and program karana peluang EEPROM. Next one, blank multiprocessor or multiprocessing cores in a single work together to complete a single job. We call it as parallel computing. So in here you have multiple processors or multiple CPUs are working together, okay, to solve a common problem. Blank is made up of connecting wires, the CPU, the main memory that is identify a particular location. Made up of the main memory that used to identify location. Locations के लिए क्या address bus. Address bus is made up of connecting of wires connecting the CPU with the main memory that is used to identify a particular location. Nice. There are three types of buses. What are these bus? Which is available inside the CPU. CPU will a high speed link that connection with connecting all the components. We call it as a bus, which is where inside the CPU. Make it there are three types of buses: address bus, data bus, and control bus. Address bus will issue location, content, and commands. Right. Hmm. Next one, okay. You are given a logical space. So they have given pages from 0 to 32. So number of pages will be how much? 64 pages, you know. Offset Kavilla goes from 0 to 1023 killing offset 1024. So make a tamai metaning image in the single page mixture information. Give the number of bits allocated for a page. Page size is going to be number of page size. Okay, page size. And the offset is also given. So now page size thamai offset. Page size is going to be the offset. So what is the offset? 1024. Comma the 0 ke patango the 1024 to the power 10. So 10 bits. 10 bits. Total number of bits in the virtual address space. Number of pages is equal to virtual address space divided by what size? Page size. Now, how many pages are there? 64. Done in a page size is 1024. So this is 1024. So now 2 to the power 10. Abhi 1024 vidhirigam ko. So 2 to the power 6 into 2 to the power 10 x. That is x is equal to 2 to the power 16. It is equal to 16 bits. So how many bits are there? 16 bits. Using 16 bits, what is the capacity in KB? Using 16 bits, you can generate to the power 16 addresses. Each address, if you give a byte, a last class byte not, you can divide as to the power 6 into. I'll write this one here. Third one. A manang to the power 6 into to the power 10. In byte addressable, we know this is KB 64. So the size is 64 KB, 10 bits, 16 bits. What is the capacity of a page? Page use kernel, page size is how much? 10 MB, sorry, 10 bits. That is to the power 10, that is 1 KB. To the power 10 killing 1 KB. An interesting question, but make sure that you all know the basics. Basics you will feel it difficult, especially when you are tackling these kind of questions. Basic it's not that you can't do it, Nime. You all forget it because you don't keep on revising. No, that can be one of the issue. So remember, okay, in operating system, I'll go with a summary. Okay, make a liya ganda. Summary Okay, so let me show you an example like this. In your computer, we do have the RAM. RAM is known as the main memory. Now, main memory is divided into more blocks called as frames. Okay, hard disk के तीन data तमाई we all have to get it. So hard disk की एक portion of memory we call it as the virtual memory. Now these virtual memories are also divided into small blocks called as page. We have to map the pages to the frame. So make it in a data ticker. Make it in a data ticker. You have to put it to the frame. But the problem is you can't take it everything at once. So we map into a table and later by it will get mapped. Map page map table. Simple. So things you all have to know: the size of page map table, number of pages, number of frames. Excellent. Me equations to not full game of understood? Sure. Got it. That's how we are going to go through. Okay. Nice. Make a device karanda. I will also, there is a YouTube video, okay, especially in our YouTube ke dala ribba midnight session Riyas Rushard Kela. So you just search it as midnight session Riyas Rushard. We will be able to get when make midnight session era OS. This one. When make I have done the complete revision class. Okay, page number, frame number, ඔක්කොම දාලා තියෙනවා. So මේක හරියට කියලා පොඩ්ඩක් in detail බලා ගන්න. In here I have done it. They have recommended me. මේක තමයි තියෙන්නේ. Good. Right. Next one, B part. We are going on towards the B part. Booting up process. When you start the computer, when you turned on the computer, the BIOS starts. Number one. Once the BIOS starts in there, the BIOS checks the CMOS, then the bootstrap order, and the interface comes in. 4312. Perfect. Why can't BIOS configuration be stored in a ROM instead of a CMOS? Now, first you'll have to know what is BIOS, what is CMOS, why cannot. Okay. So BIOS is basically used to hold, okay, the startup configuration settings. CMOS will hold user defined or user defined settings. Startup configuration program and the user defined settings mostly CMOS. Why cannot? Since ROM cannot be changed. Okay, ROM content cannot be changed. CMOS or else user defined settings should be saved or stored in a temporary location. BIOS holds startup configuration program. CMOS holds user defined settings. Why cannot? Since ROM content uh, cannot be changed, user defined setting should be stored in a temporary location. Number one, that's the main reason. If not, you can store it in BIOS. Another BIOS එකේම දාගන්න පුළුවන්. Okay. ඔයාලන්ට BIOS එකේම දාන්න පුළුවන්, but the BIOS is permanent storage in there. You can't do it. Okay. ROM මේක තව ටිකක් අපි add කරන්නත් පුළුවන්. අපි මෙහෙම add කරත් it will be more better. Okay. මේකේ content එක තවත් හොඳට යයි. Okay. Example, we'll do it in this way. ROM is a read-only memory whereby the content in the ROM cannot be altered frequently. Thereby, user-defined settings must be stored in a temporary location. Perfect. With that, we comes to the end of a merit paper 4 series, and this session we discussed about the MCQs and a part 2 question. With more paper series like this, we will be meeting you all in an upcoming session. Make sure you share these informations with your friends about our classes. We are doing classes in online, physical. Also, we do give playbacks. So make sure you spread the word, and see you all in another paper series with merit paper 4. Until then, assalamu alaikum. Take care and have a nice day to all of you.